Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the differences between physical adsorption and chemical adsorption, students. This topic is from the surface chemistry lesson. Second PUC syllabus, students. Okay, na? So first I'm going to discuss about the what is the definition of physical adsorption and what is the definition of chemical adsorption, students. So first, coming to the physical adsorption, what is the definition? See, students, physical adsorption. Physical adsorption. What is physical adsorption, students? Physical adsorption means it is the phenomenon in which adsorbate and adsorbent, adsorbate, adsorbate and adsorbent both are held together by the van der Waals forces, students. Okay, both are held together by van der Waals forces, adsorbate and adsorbent. Clear? So both are held together by held together by both are held together by van der Waals forces, van der Waals forces. Clear this one? So adsorbate and adsorbent both are held together by van der Waals forces, students. That means these are the weak forces, weak attractive forces. Adsorbate, that means in between the adsorbate and adsorbent. For example, this is the adsorbent. Now these molecules are adsorbate molecules. Okay, these are adsorbate. Okay, so in between the adsorbate and adsorbent, nana, there is a weak bond, students. That means van der Waals forces. Clear? This is the weak bond, students, weak attractive forces. So like this will be the, so weak bond is formed. Clear? So that is nothing but physical adsorption. So in the physical adsorption, you can take one example, students, setting off layer of dust particles on the furniture. So what example we can take, nana? Setting off layer of dust particles on furniture. Clear? On furniture or wooden articles, students. Clear, amma? Setting of layer of dust particles on furniture. So we know that in your classrooms, nana, suppose any bench you take, desk, on that surface, nana, dust particles will be there, correct or not? So these dust particles adsorb on the surface of the furniture, students. That means the dust particles, and between the dust particles are calling as adsorbate, and the surface of the furniture will call it as adsorbent, students. Between the adsorbate and adsorbent, nana, there is a weak bond, weak attractive forces, those are van der Waals forces. Clear, nana? So this one we can say the example, nana, setting off layer of dust particles on furniture. In your classrooms, you can observe, students, on your desk, on the surface of the furniture, students, if you observe, there is a dust particles, correct or not? So dust particles will be there, dust particles. That means in between the dust particles and the furniture, van der Waals forces will be there, students. There is a weak van der Waals forces, those are the weak attractive forces. Weak bond is formed between the dust particles and the furniture. Clear this one? That is a physical adsorption. Now coming to the chemical adsorption, students, see here, what is the chemical adsorption? Chemical adsorption. What is chemical adsorption, students? Chemical adsorption means, in chemical adsorption, adsorbate and adsorbent. Adsorbate and adsorbent. Okay. Both are held together by chemical bonds. Both are held together by chemical bonds, students. Clear this one? Held together by chemical bonds. Now see, nana, this is the adsorbent. This is adsorbent surface. These are the adsorbate molecules. Okay, in between them, adsorbate. In between them, chemical bond is existing, understanding. So there is a chemical bond, strong bond is formed. Here it is a weak bond, van der Waals forces, okay, but here chemical bonds are formed, understanding students. That means in between the adsorbate and adsorbent chemical bond is formed, that is calling as chemical adsorption. If there is a weak van der Waals forces are there, that is the physical adsorption, students. Here we can take one example, Anna. Chemical adsorption example, students. Chemical adsorption, what is the example we can take, Nana? Chemical adsorption, painting on a furniture. Painting on a furniture, students. Painting on a furniture. This is the chemical adsorption example, students. So chemical adsorption definition completed. Now I am going to discuss about the characteristics of physical and chemical adsorptions. After that I will discuss the differences between physical and chemical adsorption. So first of all, characteristics. Characteristics of physical adsorption. First I am going to discuss about the characteristics of physical adsorption, students. So what are the characteristics, Nana? Physical adsorption. First point, students, physical adsorption, it is a non-specific, students. It is non-specific. That means adsorbent has no specific preference for the adsorbate, students. Clear this one. That means, for example, furniture. On furniture, dust particles will be there, na? That means only dust particles only should occupy the surface of the furniture. Is there any specific preference, students? That means that furniture is having the specific preference, only dust particles or only chalk powder, like that. There is no any preference, students. That means adsorb on that furniture, any type of dust particles can adsorb. That is calling as non-specific, students. Are you following? Any type of particles can adsorb on the surface of the furniture, okay na? So only this dust particles, that particles, like that, there is no preference. Clear this one. So it is a non-specific, students. Next, second point, students, nature of the adsorbate. Nature of the adsorbate. Nature of the adsorbate. Now see, students, here nature of the adsorbate. So that means the physical adsorption depends on the nature of the adsorbate, students. Here we can say that nature of the adsorbate. In nature of the adsorbate, students, we know that more liquefiable gases, more liquefiable gases readily adsorbed. More liquefiable gases are readily adsorbed. Correct? Readily adsorbed. See, students, more liquefiable gases readily adsorbed. Liquefiable means what, students? The gases which are readily convert into the liquid state. So those are liquefiable gases. Understanding? So how can you understand, students? The gas is, it is easily convert into liquid state. This gas is not convert, like that. How to identify, students, the gases which are easily convert into liquid state? See, here you have to remember two important points, then you can easily understand. See here, how to remember this. See here, important points, note important points, Nana. Heavier the molecular weight, okay, molecular weight, faster the liquefaction, students. Faster the liquefaction, okay. And next one, faster the liquefaction. Next, lower the molecular weight, faster the diffusion, students. Okay, that means the molecules which have the high molecular weight, students, they have the they can liquefy, they can convert into liquid state fast. The faster the liquefaction, okay now. So lower the molecular weight, so those are undergoes diffusion, fast diffusion. Correct or not? Fast diffusion. So we know that the molecules are having weight. Correct or not? Molecules are having the weight, students. Okay, now see, students, suppose here in classroom, suppose two boys I'm taking. In two boys, one boy is thin boy, another one is fat boy. Suppose I conducted one running competition, students. Then which boy will select the students? Because who runs fast? The thin boy only can run fast, correct or not? Because his weight is less. Are you following? But if you take the fat boy, his weight is more, so that's why he cannot run fast, correct or not? So that's why less weight is there, can run fast. More weight is there, they can run slowly, correct or not? So like that only in molecules also, having molecules also, they can, some molecules can run, some molecules having the less weight, some molecules are having the more weight, students. So the molecules which have the less molecular weight, they can run fast. The molecules which have the more weight, they can run slowly, correct or not? They can move slowly. So that means, madam, how to identify the molecule is having the lesser weight or more weight? We know that atomic weights, by using the atomic weights, we can calculate the molecular weights, correct or not? Okay, now see, students, for example, CO2 and hydrogen I am taking, CO2, H2, which is having the more molecular weight, students? Carbon. For example, CO2, if I take, carbon atomic weight is 12, two oxygens are there, 32, total 44 weight, 44 grams, correct or not? CO2 weight is 44 grams and H2 weight is how much, students? 2 grams. Now which is having the more weight, Nana? CO2 weight is 44 grams, hydrogen weight is 2 grams, correct or not? So which is having the more weight? CO2 is having the more weight, more molecular weight. So that's why CO2 is easily convert into liquid state. ಅರ್ಥ CO2 is easily convert into liquid state because its molecular weight is more. H2 weight is less. That's why it can diffuse fast. That means diffusion is nothing but the molecules move from one place to the another place, students. So hydrogen is the lesser weight, so that's why it can run fast. That means it can move from one place to the another place. But coming to the CO2, carbon dioxide, it is having the more weight, so that's why it can easily convert into liquid state. Are you following, students? So here what I told you, nature of the adsorbate. So that means more liquefiable gases readily adsorbed. So the gases which are easily convert into liquid state, those are readily adsorbed, students. Clear this one? Readily adsorbed. Okay, now which are easily liquefiable? More molecular weight is, more molecular weight molecules are can easily liquefiable. Are you following? Understanding, students? Now I am taking the one example. See, students, activated charcoal. For example, activated charcoal. Activated charcoal. Activated charcoal, it absorbs the gases in the following order. In the following order, students. So in which order, Nana? SO2 greater than CO2 greater than H2. So activated charcoal, when it is shaken with these gases, students, which gas can easily adsorb on the surface of the activated charcoal? These gases are acting as adsorbate. These are adsorbate. Now this activated charcoal, this one is acting as, this activated charcoal is acting as adsorbent. Clear? Adsorbent. So on this adsorbent, which gas is first adsorbed? For which gas is first adsorbed, students? SO2, because it is having the more weight, 64 grams its weight, correct na? Sulfur 32, 2 oxygens kada, 2 oxygens means how much weight, students? 32, total 64. CO2 weight is 44 grams, this is 2 grams. Now which is having the more weight? SO2. So that's why SO2 is having the more weight, so that's why it can easily convert into liquid state. The gas which is easily convert into liquid state, that can easily adsorb. So that's why SO2 is first adsorb, next CO2, next H2. Clear this one? That means the physical adsorption is depends on the nature of the adsorbate. This is adsorbate kada, nature of the adsorbate. That means which gases are easily liquefiable, those are readily adsorbed. This is readily liquefiable. Because its weight is more. That's why it is readily liquefiable. That's why it is readily adsorbed on the activated charcoal. Clear this, students? This is the second point. And coming to the third point, surface area. Whenever surface area increases, the amount of adsorption also increases. Clear, Nana? Surface area. Third point, surface area. What is surface area, students? Surface area increases. Surface area increases, students. Adsorption also increases. Adsorption also increases, students. Clear, students? So this is also increase. This is about the characteristics of physical adsorption. Now I am going to discuss about the characteristics of chemical adsorption. Now see, Nana, characteristics of chemical adsorption. Characteristics of chemical adsorption. So what are the characteristics, students? Chemical adsorption, what are the characteristics? So first one is, it is a specific, students. It is a specific. First point, it is a specific. Specific means what? Adsorbent has the specific preference for the adsorbate. Are you following? So that means only that is the specific. For example, in the case of Haber's process, ammonia preparation, N2 combined with 3 moles of hydrogen produces 2 moles of ammonia. That means in this reaction, iron is acting as a catalyst, students. Iron is acting as a catalyst. That means in this reaction, iron is the, it is specific, students. Any another catalyst if I take, this reaction does not takes place. Are you following? That means for this reaction, iron only suitable. Iron is the, it is a specific catalyst. Are you clear this one? So like that anamata. Okay, it is a specific, students. Chemical adsorption. That means adsorbent has the specific preference for the adsorbate. Clear that one? So that is nothing but chemical adsorption. Chemical adsorption, students. Next, coming to the second point, students. Second point, it is irreversible nature. Correct? It is irreversible. Irreversible. Irreversible nature. Why, students, irreversible nature? For example, if I take physical adsorption, it is a reversible nature, because we can take the example, students, setting of dust layer, okay, on the surface of the furniture. So we can remove back, that means we can get back the dust particles again from the surface. As are not, first dust particles are adsorbed on the surface. Okay, now if suppose if you want to collect back that dust particles, we can collect back, yes or not? So that means here we can get back the dust particle. That's why it is a reversible process. Which one? Physical adsorption. Now coming to the chemical adsorption, it is a irreversible nature. It is irreversible nature. For example, painting on the furniture, students. Painting on your furniture. So painting on your furniture, paint we can get back, students, again as it is, we cannot get back. Are you following? So paint applied on the furniture, students. Okay, it is a forward reaction. In the backward reaction, we can get back again paint as well as it is. We cannot get, correct or not? So that's why it is a irreversible nature. Clear this one? And coming to the third point, students, it is a surface area. Surface area increases, students. Surface area increases, and chemical adsorption also increases, Nana. Chemical adsorption also increases. Clear, students? So these are the characteristics of physical and chemical adsorptions completed. Now I am going to discuss about the differences between physical and chemical adsorption. What are the differences? Now see, students, physical adsorption, first one, physical adsorption, and second one, chemical adsorption. Now I'm going to discuss about the differences between physical and chemical adsorption. Now see, students, first physical adsorption, first point, it takes place at the low temperature. It takes place at the low temperature, students. Physical adsorption, it takes place at low temperature. Clear this one. It takes place at the low temperature. Now coming to the chemical adsorption, students, chemical adsorption, it takes place at the moderate temperature. It takes place at the moderate temperature, students. Moderate temperatures. Clear, Nana? Moderate temperatures. Now coming to the second point, students, it is a multi-layered. It is a multi-layered. Here second point, it is a unilayered. Okay, it is a unilayered. Multi-layered, that means here for example in your classroom benches will be there. On the desk, nana, so many particles, dust particles will be there, and chalk piece powder will be there, correct or not? That is a physical adsorption. That means it, so many dust particles layers are occupied on the surface of the solid, so that's why we'll call it as it is a multi-layered. Now coming to the chemical adsorption, it is a unilayered. That means only suppose I am taking the painting on the furniture, so only painting is the, it is painting is only one layer. But again if I want to take any another paint on that, that paint I can I can apply on the surface of the furniture, students? No, because if I apply, suppose first paint is green color, nana, green color paint is there on the furniture. Okay, now only one layer we applied. If I want to suppose apply second layer red color paint on the surface of the furniture, then that can adsorb on the surface of the furniture, students? No, second layer red color, whichever the paint we are applying, that is adsorb on the surface of the, which one, students? Green color paint. That means it is not adsorb on the surface of the furniture. Only one layer is possible on the, if you take the second layer, students, because second layer if you apply, that is placed on the uh, which one, students? Green color paint. Are you following? That means it can adsorb, that means the furniture cannot adsorb the red color paint. Are you clear this one? So it is a unilayered, students. Okay, namma, multi-layered and unilayered. Now coming to the third point, students, what is the third point? Now see, third point. Third point is enthalpy of adsorption. Enthalpy of adsorption. Enthalpy of adsorption is less, students. It is low. Okay, that is 20 to 40 kilojoule per mole. Clear, students? How much enthalpy of adsorption? It is low. And here enthalpy of adsorption is enthalpy of adsorption. Adsorption is more, nana, here. Enthalpy of adsorption is more, that is 80 to 240 kilojoule per mole, students. Okay. What is enthalpy of adsorption? Now see, students, here in the case of physical adsorption, we know that between the adsorbate and adsorbent, okay, between the adsorbative and adsorbent, nana, there is a weak van der Waals forces will be there, correct or not? Weak van der Waals forces, understanding, nana? So weak van der Waals forces will be there, so that's why during the formation of weak bond between the adsorbative and adsorbent, very less energy is released. We know that during the formation of bond, energy is released. During the breaking of bond, energy is required. Correct or not? Here what I told. During breaking of bond, energy is required. Correct or not? Energy is required. During the formation of bond, energy is released. Okay, ma, energy is released, students. Clear? These 2 points you have to remember, students. See here. Now here in between the, in physical adsorption, we know that what is the definition physical adsorption? That adsorbative and adsorbent both are held together by the weak van der Waals forces. That is nothing but there is a weak bond is formed between the adsorbative and adsorbent. Correct or not? So that means during the formation of weak bond between the adsorbate and adsorbent, very less energy is released, students. Are you following? Very less energy is released. Okay, now coming to here, enthalpy of adsorption is more, because in the chemical adsorption between the adsorbate and adsorbent, there is a strong chemical bond is there. Are you following? So that means during the formation of chemical bond, more energy is released. Are you following? So more energy is released, students, that is 80 to 240 kilojoule per mole. This much energy is released because due to the formation of the chemical bond, strong bond, more energy is released. Are you clear? Now I'm going to discuss about the temperature effect. Temperature effect. Fourth point, students. Fourth point, temperature effect. Temperature effect. What is temperature effect, students? Here in the fourth point in physical adsorption, Nana, temperature effect. So how it is affecting the physical adsorption? Temperature effect, correct? So temperature effect, how it is affecting, students, temperature. Okay, ma, temperature effect and pressure effect in the next video I will discuss, students. Okay na. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, Nana.